Hello YouTube, RJ. Today we're going to pick up where we left off in the HP 428B restoration video. We're going to continue on here and let's see if we can get somewhere with this thing. Okay, I'm back and I have went down the rabbit hole. Lots to talk about since we last spoke. I put this new unit up on the bench and pulled all the tubes, tested them. I found a dead shorted tube. I found a couple really weak tubes. So I replaced them. I've got all good tubes in it. I powered it up and still same thing as when we tested before with it, nothing. So I immediately went and checked for these 272 volts by getting on, if you can see right here, there's a test pin TP5 for nothing, nada. Flipped it over, thought transformer problem maybe. So went back, checked fuses on the back, good. Checked power in the transformer, good. Power coming out of the transformer, great. Let me grab the power supply diagram here. You've got the two fuses here in the system. They were fine. Had power to the transformer. Went over and found the two 6.3 taps. Power coming out great. Come over here and found the high voltage side and was getting 400 and some volts, around 400 volts AC. Went over and found the diode bridge here, checked across it, was getting, was getting 320, I think, out of an AC. Here I was getting around 400, just over 400 volts, makes sense. I knew I was getting power. Notice this fuse here, F3, so I hunted that down. That turns out to be right here, if you can see on the board by my finger. It was blown. It's a half amp fuse. I didn't have any half amp fuses. I also noticed while looking, as you might be able to make out, there's a couple new nice blue resistors right down in here. Get something to point with a little better. Right down here, see a couple newer looking resistors. There was some burn up carbon resistors. I mean, burnt slap up here. Let me give you one was coming apart. I think you can get a pretty good view there on that one. You can probably see he's seen better days. His neighbor next to him was swollen, looking really bad. So I went in and replaced those, put some new fuses in there. Kind of wondering why they were getting so hot. A little nervous about that. Did have a 3 amp fuse, but didn't like the idea of that. So what I did is I went ahead and I put my meter across, pulled the fuse out, put the meter across it, and turned it on and checked amperage. And I was pulling about 50 milliamps. So I wasn't anywhere near the 500 milliamp the fuse is rated for. So I knew I didn't have anything shorted out. I assumed the shorted tube did that. I'm pretty sure that's probably what did that. So I went ahead and I popped that 3 amp fuse in there. I'll have to change it out once we get everything working. And so when I did that, I then had my 272, but it was about 260. So I adjusted the pot here and got us up to 272. Unfortunately, I started smelling the stink of an old capacitor burning up, and I found it over, I don't know how well you can see it here, but this capacitor right here, the end has come off. It has self-disintegrated right in here. She's seen better days. Wondering, why did it blow up? So I went over and found that, and it's a 50 volt capacitor, and I put my probes across it and had a couple hundred volts on it. So, or I think it was like 170 if I remember right. So obviously I know why that capacitor failed, but why do I have that voltage there? So while this is going on, I'm wanting to know why these resistors burn up, and I noticed that they're getting pretty warm, and these are 1 watt resistors. I think, let me see, are these 1 watt? Yeah, these are 1 watt resistors. So I thought, So I put my meter over here, and if you can make it out here, let me find, blew it up here. This is the one that really burned up, the 5600. It's supposed to have 12 volts on one side. This side has 174 volts on it. This side has your full 272. Well, interestingly enough, if you follow that 272 over, it ends here on one leg of that C12 that's burnt up, the 50 volt capacitor. Well, if you put 272 volts on one side, that's right, it was like 272 volts. 272 volts here and ground here across a 50 volt capacitor, I can assure you it will fail. Electrolytic came apart. So that's got to be changed, but I got to find out why I've got all this voltage here I shouldn't have. So I've looked at the circuit quite a bit, and one of the things that I've found is I'm trying to figure out where would it be getting that kind of voltage down here. And right here, if we look at C15 and C13, they go up to high voltages. This one goes up to about 125 volts there. This one goes up to about 225 volts. I'm thinking one of these capacitors, probably C13, maybe C15, are shorted. And if they're shorted, they'll pass DC. Normally they should only be shunting AC, but if they're passing DC, leaking bad, that's where I'm getting this high voltage from. I don't see where anywhere else I would get these kind of voltages from. So, I mean, other than these resistors being like ridiculously low, this is a 43 meg, a 1 meg, unless these are way out of, I mean, like unbelievably out of tolerance. That could be, but my thought is probably one of these capacitors or both are shot. So I'm going to try looking at C15 first. I'm going to pull it out, check it out, and then try C13. I don't have ceramics to match those, but I've got some films, high voltage films. That might be what gets replaced in there, at least temporarily. Let's see, what else have I found? There was a number of things I dealt with. Fuse, resistors, too high voltage. Oh, 12 volts. I'm not getting 12 volts, I'm getting 174 volts. I went over and chased down the circuit for that to here. And at this point right here on pin 7 of V10, I should have 94.5 volts. I'm getting 85 volts. I'm a little low there. Then this reference voltage reference here is 82.5 volt drop. Is supposed to get me 12 volts. I'm getting 6.8 here. But the 12 volt at this resistor is 174 volts. So I've got some stuff going on there. I'm a little suspicious I've got an issue down here, but I'm reading low here, not high. So I might have a capacitor leaking, bringing high voltage down. I don't know. I'm one disaster at a time, but I have got this thing to power up. The meter does move some. We still got a lot of issues. So anyway, I'm working through that. So right now what I'm going to do, I'm going to pull these capacitors. I'm going to check them out, replace them if I need to, see if I can get this voltage under control. And, you know, obviously before I replace that capacitor, I've got to get the voltages down where they need to be. So that's where I'm at. That's what I'm doing. I'll come back and let you know how I'm making out, show you what we've come up with so far, and as soon as I get a little more progress done. So hang in there. I'll see you in a little bit. All right, I'm back. It was not C15, but it was C13. C15 seemed to be okay. Pulled him out, checked. Again, still had high voltage on that side that would here. Had high voltage here, had high voltage there. Put him back in, tested him on the LCR, he seemed fine. Pulled C13, still have high voltage on this side. Got 12 volts here now. Let me show you. Go ahead. So if we go here where we're missing this capacitor right here, hopefully you can see enough there to see. Get my hand where you could see better maybe. Okay. And I kick him on. We look at the meter over here, we got over 300 volts. But if I go to this side now where I had, you know, 100 and what did I have? 272 volts. I now have 48, 50 volts. So we've dropped dramatically the voltage. I thought I had 12 a minute ago when I tested this. Anyway, we've dropped voltage quite a bit. So it definitely was leaking voltage from there. Couldn't figure out if I'm leaking voltage somewhere else. Maybe I misread it. Maybe it was 52 and I thought it said 12, but because I was kind of standing looking at it kind of funny, but I thought it was 12 a minute ago. So still got to keep looking, but we found one of them. I don't have the right capacitor for that, but I made one. I took 2.2 microfarad films and turned them into a 0.1 by putting them in series. It's a kludge, but it'll work. It's all I got at the moment. So, you know, if we get this thing working, I'll go back and change the fuse, probably change this to the right thing, slowly work on it. But now I'm still got a higher voltage than I should. Not near what I did. A lot more within range, but and that may be correct. I don't know that I should have 12 volts. I should have 12 volts on one side of this resistor. Let me check that. Let me go check this 56. Set 5.6K. What do we got now? We got 300 volts there. And 272 there. I'm going crazy. How am I getting all these extremely high voltages? Now I've got a higher voltage here than I did there. Let me get that capacitor back in, and we'll test it then and see where we are. All right, you're not going to believe this. Well, you probably will. If you work on electronics, you probably will believe this. Remember, I had those two burn-up resistors, R26 and R30, that I replaced. That's the two, you can see there are newer blue 1 watt resistors in there. Well, I took the schematic, zoomed in on the section where we were having high voltages where we shouldn't. We got it down to about 55 volts or so, if you remember, from a couple hundred volts. That's what blew up that one capacitor, electrolytic capacitor. I'm sorry, my desoldering gun's warming up. It'll shut up in a second. Anyway, here's R30 right here. And it's one of the ones I replaced. And here's R28, which is over here. And if you notice, I've marked down, I went through all the resistors and looking for resistors out of value that might be causing this higher voltage than we expect. And we were definitely leaking here because we had a couple hundred volts here, and we got it down to 50 volts by replacing that capacitor. So we were, or I'm sorry, C13. So we were definitely leaking a lot of voltage through there. So I went ahead and replaced C15 anyway. I had to put it back in. You know, I said, you know what? That one failed. This one will fail. I went ahead and put a new one in. So that's been replaced. But I just couldn't figure out how I was getting the voltage here. So I went to look for this 40 volts here, and I wasn't getting 40 volts. I was getting much higher. So I said, okay, well, let me trace all this out because some of this isn't making sense. So I started tracing and I said, okay, well, pin 7 of this tube hooks to this side of R28. That'll tell me which side of the resistor. So I did, sure as the world. The top of it's the one going to the pin, just as it shows in the schematic here. So then I hopped over to the R30 56 5.6K resistor, and I did continuity from this side of the R28 to both sides, and I had tens of kilo ohms of resistance. It's like, no, that should be connected. Maybe that's my problem. Maybe there's something going on here. So I started tracing and trying to figure out, and nothing I did, I could not find a way that 28 hooks to R30. But then I figured out that it does hook to R26, the other one I replaced. Oh, here's my locator. So it was supposed to connect to one of the sides of this resistor right here, but it does connect directly to here. So I flipped over and looked and followed the traces, and indeed it hooks to 26, not 30. I thought, what the heck? And then I remembered, well, you know, there's a lot of errata for this thing. So I started digging through the manual changes, and lo and behold, let me find it. One of these documents. What'd I do? Oh, it's here somewhere. Sorry about that. Bear with me a moment. Oh, here it is. So you go through these pages and pages of changes, and you run across one right here. If you look real careful, it says, oh, by the way, on the diagram, the schematic, interchange R26 and R30. So R26 and R30 are backwards. So when I replaced them, I put them in the wrong place. I put them back where the schematic showed and what was supposed to be there. But I've got to swap those two resistors now. So that's why my desoldering iron was warming back up. I've got to get those out and swap them around and see what changes that has. I'm assuming it'll be good, since one's a 10K and one's a 5.6K. So let me get those swapped around. I'll come back. We'll see what kind of changes we got then. Well, that did it. We got our 12 volts. We've worked through the problems one by one until we got this thing under control. So we got 12 volts. I think we're ready to go back and start through the normal check procedures now. Now that I've got high voltage working correctly, we're 272 on the button. We've got 12 volts coming out. There's a couple other voltages we need to check that I had started into, but immediately we didn't have any voltage on the high voltage at all, and that kind of led down this path. So what I'm going to do now is I'm going to reorganize all my manual and everything, get set up, and start walking through. But this will be the end of the video here, and I'll pick up in the next video. We'll start going through the troubleshooting steps of this thing, checking everything along until we find another issue we've got to deal with. So hey, thanks for hanging out with me. I hope you found this entertaining. Oh, all the mistakes as far as the swapped schematic parts and all of that. What a ball. But hey, that's what electronic repair is all about. It's figuring out puzzles, troubleshooting issues. Just remember, if you're going to work on this kind of equipment, be careful. There's a lot of voltage in here, and it can be lethal. So hey, thanks for hanging out with me. Hope you enjoyed it. Hope it was entertaining. And most of all, I hope to see you in the next video.